Yes, class. So yesterday we had stopped at the LCR circuits. So if we'll study LCR circuits, then the individual RC circuits and LR circuits also we'll be able to do. So impedance triangle was left to be discussed. This is a triangle which just helps in the derivation of impedance. Now, what is meant by impedance? See, when we had the individual resistance circuit, resistor R was the resistance which was providing the opposition. Here we had resistance. Here we had XL. Here we had XC for individual circuits. Correct. But if we combine all the three, there will be a net resistance for the circuit. That net resistance is known as impedance. Okay. So impedance triangle, see again, as I have told you, we have to resolve two vectors first, that is inductance 1 and capacitance 1. So either it can be XL is greater than XC or XC is greater than XL. So this triangle we use to represent it. So this is XL minus XC, this is resistance, and this one is their resultant. This you can relate it with E naught, you can relate it with VL minus VC, correct? And this you can relate it with VR. Now see, if you will apply Pythagoras theorem, E naught square is equal to VR square plus VL minus VC whole square. Now E naught square is equal to I naught R whole square plus this is I naught XL minus I naught XC whole square, right? I've just substituted the values using Ohm's law. So if I take I naught square common from all of this, I'll be left with R square from here plus XL minus XC square from here. Now class, if I write the value of I naught square will be equal to E naught square divided by this term. I naught square is getting multiplied here. So if I want to find out the value of I naught square, I'll have to divide this. So this will be R square plus XL minus XC whole square. From here, I naught is equal to E naught divided by under root R square plus XL minus XC whole square. Now class, if you compare this equation, can you see I is equal to V by R in every case which we studied in the last class also? We had seen that we had to compare it. Earlier, XL only came in the denominator for inductive circuits. For capacitative circuits, we only had XC in the denominator. Right, so it means impedance Z, that is the net resultant, is R square plus XL minus XC whole square. This is the resultant, but this is the case when XL is greater. If XC is greater, same derivation class, it's just that XC minus XL square we'll get. So what is meant by impedance? Impedance means effective resistance of series LCR circuit. It's like you have the net resultant resistance for the entire circuit, LCR circuit. All right, now using this impedance triangle, one or two things also we can calculate. Let me discuss that, then you can note down all these. If I write tan phi from here, phi is the phase difference, this angle is phase difference. So according to trigonometry, tan theta is perpendicular by base. So it will be XL minus XC by base, that is R. And if I write cos phi, cos theta is base by hypotenuse, so it will be R by Z. See, when XC is greater than XL, in this triangle, if I write perpendicular by base, this will be XC minus XL by R, right? Perpendicular by base. But can you focus on cos theta? Cos theta is still equal to R by Z. So remember, this cos theta is universally true for all the quantities. All right. So you have these formula. You can use any of these formula. It's just that depending upon which is greater. See, yesterday I was telling you the same thing. If three vectors are given like this, so you will solve these two first. If this is greater, so resultant will be VC minus VL will be in this direction with R. If lower one is greater, so this will be in this direction with resistance. Correct? This we already studied in the last class. The way you have two vectors, that's how you have to solve. You cannot just subtract or add all of these. You have to solve individually. And once VL minus VC is done, what you have to do further, for the further information, we have done this. Start writing it down from here. Whatever doubts you have regarding LCR circuits, you can clarify. Then after this, we'll practice numericals. Lisa, you do not join the classes of the earlier batch. We have completed semiconductors also. You did not join yesterday or day before yesterday, Aliza.
Ma'am, I have my offline classes at that time.
Okay, okay. So
Yes,
when
ma'am.
do you get free? You are available at this timing only.
Yes, ma'am.
Okay, Aliza. See class, just one more thing. When XL will be equal to XC, we'll say LCR is purely resistive. This I'll discuss with you. That's why I'm not focusing on this. Just write down these points. We'll see resonance case, then this will be clear. Write down this question. I'll discuss it right now. This just make it a note point for this. So this question says, determine the impedance of a series LCR circuit if the reactance of capacitance and inductance are 250 ohms and 220 ohms respectively. Resistance is also given. So see, you have the value of resistance as 40 ohms. You have the value of capacitive reactance as 250 ohms. You have XL equal to 220 ohms. Clearly, we can see XC is greater than XL. So which formula we will use? R square plus XC minus XL whole square under root. So Z will be R square. So 40 square, 250 minus 220, 30. Okay, 50 is the answer then. 50 ohms will be the answer. Okay, just write down this, then I'll discuss another topic, resonance, which I was mentioning. First, write it down. The resonance condition of LCR series circuit means basically your inductive reactance and capacitive reactance both are equal in magnitude. Okay. Also, you get the maximum value of current. The value of current is maximum because the resistance decreases. See, this is the formula. If I say XL is equal to XC right now. Okay, XL is equal to XC right now. So what will Z be? R square plus XL minus XC, whether it's whole square, under root, anything, these will be cancelled. Same numbers, it will be 0. This term will be 0. So Z will be under root R square. That is, Z is equal to R only. See, in the previous question, look at this example. Here resistance is 40. When you had XC, XL in your system, your answer was 50. If XL and XC were equal, this term wasn't there. Resistance would have been 40. Impedance would have been 40. So 40 is less, 50 is more. It means resistance is decreasing. So here resistance decreases. As a result, what happens? Current increases because you take any current. IRMS is equal to VRMS by R. You take I naught is equal to E naught by Z. You take any value. Current is inversely proportional to resistance. Here resistance is decreasing. So current increasing. All right, so impedance is minimum, current is maximum. This condition is called resonance. And what happens to frequency in such condition? XL is equal to XC. Correct class? XL is equal to XC. How do we write XL? Omega L. How do we write XC? 1 by omega C. Correct class? Let me just bring this L in the denominator. Let me just bring this omega in the numerator. So what do I have? Omega into omega is equal to 1 by LC. Omega square is equal to 1 by LC. Omega is equal to 1 by under root LC. But this is the angular frequency. What about the linear frequency? Omega is equal to 2 pi nu. Frequency, that is this frequency. This is omega divided by 2 pi. Correct. So 2 pi is already there. And what is omega? Omega is 1 by under root LC. So this is the formula of linear frequency also. Note down this topic of resonance, and this is very important class. When you are revising for your finals, I'll suggest you always when you are doing LCR circuit, start with resonance, do it with your maximum potential because resonance is very, very important. Sidra written. Sidra is also written. Other students, Deborah, Amna has informed. Okay. See, this says that a resistor of 12 ohm, a capacitor of reactance 14 ohm, and a pure inductor of inductance 0.1 Henry are joined in series and placed across a 200 volt 50 hertz AC supply. All right. So calculate the current in the circuit, phase angle between the current and the voltage. And you have to take pi as 3. Rounded off value. Instead of taking it as 3.14, it's given in the question to take it as 3. Now see what, in such questions, no class, in every numerical of physics, this thing that with which I also start the numericals, I suggest you all to go by the same. See, write everything which is given. 12 ohm is mentioned. XC was mentioned as 14 ohms. XL was mentioned. XL is not mentioned. The inductive reactance is not mentioned. Rather, inductance is given. C class. See, XL is missing. L is given. How much is L given? L is given as 0.1 Henry. We know the frequency is given. Frequency is given as 50 Hertz. So cannot we find XL? Can't we find it? XL is equal to omega L. We do not know omega, but we at least know this is 2 pi nu L. Right, class? So XL is equal to 2 pi. I've already been informed that by the question that I have to take it as 3. Frequency 50, inductance 0.1. So this becomes 30 ohms. So this is also 30 ohms. Now XL is given. Now the question is not difficult. To calculate Z, we have R square plus, which is greater, XL is greater. So XL minus XC whole square you will take. Understood, class? So this is 12 square plus XL minus XC, 30 minus 14 whole square. This is under root. So see, 12 square here, this we'll take it as 144. From here 16, so this will become 256. So 0, 1, then again 0, 1, 400. Under root 400. So impedance is equal to 20 ohms. This is the answer. Now class, we know the value of impedance, but did we need to calculate it? What was the question? Current in the circuit. The issue that was arising was, we know what is the value of voltage given, but we didn't have the value of the net resistance, that is the impedance. So that's why we have calculated impedance first. Now IRMS will be equal to VRMS divided by Z. Just similar to your Ohm's law, I is equal to V by R. Is this okay, class? Yes or no? Understanding? Yes, Hussein. You haven't responded anything today? Understanding or not? Yes, no? Or is it that just Amna and Sidra have understood? Okay, other students are also getting? Good. See, this is just simply based similar to your Ohm's law. Because this is alternating current, this is not a direct current. So we have to apply different methods. Every student has responded except you, Mir Hussain Ali. You present in the class or not? I should get the reply in the chat column, or you should unmute yourself by the end of question. Otherwise, I'll simply remove you from the meeting. So VRMS is already given as 200 volt and impedance is given as 20. So net current is 10 amperes. Okay, Sen, just keep on responding. Then only no, I'll understand that you're present in the class or not. Okay, then. Tan phi is equal to Yes, Hussein, which formula should I use for tan phi? Tan phi, you have written a formula in your notes. Which formula should be used? Yes, Mir Hussein Ali. Which formula we should use? You must have written a formula impedance triangle. There I had made you write two formula, one for tan phi, one for cos phi.
Yes, ma'am.
Yes, so what is the formula for
XC minus XL by R.
should we use XC minus XL here or XL minus XC?
XL minus XC, ma'am, because XL
XL
is
minus
in
XC. Yes, good. Because XL is greater than XC. Right. So as rightly answered by Hussein, this will be XL minus XC because this is greater divided by the resistance. So this is simply 16, 30 minus 14 we had, 30 and this was, resistance was how much? 12. So this is 12, which is 4 by 3. So how do we write the final answer as? Tan inverse 4 by 3. This is how we'll write our final answer. Write it down. One part is there that is known as quality factor. I'll discuss this graphical thing, is it? A question you all have written? Or question also I have to display? Okay, okay. Write down the question. Okay. Okay, class. Now, quality factor, Q factor means quality factor. This tells you the sharpness of resonance. Means at what amount of resistance you will get a very high amount of current. Sharpness of resonance means more amount of current. So the lower value of resistance you have, the higher value of current you have. So this blue line has been marked to show that this is the highest value of current where resistance is low. This is moderate, this is high resistance, but current is low. This is shown by this red line. Okay, so at this point, current becomes 1 by root 2 times. See, quality factor of a series resonance circuit is defined as ratio of two quantities. Now I'll tell you, this definition is very lengthy. To understand this, you have to understand this first. This is the highest one that has been drawn. Okay, and at the maximum resonance, at the resonance condition, current becomes E naught by R 1 by root 2 times E naught by R. Means it becomes 1 by root 2 times its value. Okay, 1 by root 2 times its value. This is the maximum value of current that is obtained. So see, this is the value of the quality factor that I have taken. Okay, what is quality factor? That I'll tell you the definition. So this is the resonance frequency. Maximum value, at the maximum value of current, I have taken the resonance frequency. Now, 1 point left to it and 1 point right to it, I have taken omega 1, omega 2. These are the resonant frequencies. These are all the frequencies actually. Resonance is this. So this separation, that is the difference between omega 2 and omega 1. This is called as bandwidth. What is bandwidth? This is equal to omega 2 minus omega 1. This separation, this is bandwidth. Okay. And what is resonant frequency? The resonant frequency is that frequency for which current is maximum, you can see. Now, what is quality factor? It's the ratio of this resonant frequency and bandwidth. That's it. Now come to the definition. Quality factor or Q factor of a series resonant circuit is defined as the ratio of, now look, resonant frequency, firstly, 2. Clear? Ratio of resonant frequency, correct? Resonant frequency to what? To the difference in two frequencies, these two, taken on both sides of resonant frequency. These two which are taken on both the sides, their difference in the denominator, such that at each frequency, current amplitude becomes 1 by root 2 times the value at resonance. That's it. All right, class. Now, derivation is a little lengthy. Z is equal to R at resonance. So here in this case, this will be root 2 times R. So you will write this as omega L minus 1 by omega C whole square under root R. This is the formula of Z, XL minus XC whole square. Instead of Z, I'll write this equal to root 2R. Okay, please pay attention, class. You will remember the derivation here in the class itself. It's a little lengthy. Now I'll open up the square root. So this will become omega L minus 1 by omega C whole square. Root will be cancelled. This root will be cancelled. And this will be squared up to R square. If I subtract this R square here, I'll be left with omega L minus, this will be omega L minus 1 by omega C whole square is equal to R square only. Why R square? Because 2R square minus R square will be equal to R square. This R square I have brought on this side. Now see, class. If I'll open up the roots, whenever you take this root values, you get two values, that is plus minus. I have to write this as plus minus R only, no? So means one equation will be omega L minus 1 by omega C is equal to plus R. One equation will be omega L minus 1 by omega C is equal to minus R. Fine, this is first equation, this is second equation. Clear? Now, the two frequencies, I'll write it here. This is omega 1, omega 1. This is omega 2, omega 2. Clear? I didn't write it first because it would have been very confusing. Till these two equations, it's clear. What we have done, we have just simplified it until we have reached the square root values. I hope till here it's clear. Okay, good. It's very good that Amna and Sidra keep on responding always, whether it's writing in the class or it's responding. Now see, these two equations we have obtained. Whenever you're practicing this derivation, no, that time also remember it in this manner that first you have to reach till these two equations. One part is over. Second step is add both these equations. Now, why are we adding this? You will understand later. Omega 1 L minus 1 by omega 1 C plus we are adding, so omega 2 L minus 1 by omega 2 C is equal to plus R minus R. So they'll be cancelled. Right? If you will add plus R minus R, they'll be cancelled. See, omega 1 plus L minus 1 by omega C can be, okay, from here, let's take L common. If we take L common from here, this will be omega 1. And from here, this will be omega 2 plus. Let's take 1 by C common from here. So we'll be left with 1 by omega 1 plus 1 by omega 2 equal to 0. So this will be L into omega 1 plus omega 2 plus, no, not plus, minus. Here minus is there, so I have to take minus common, not plus. This is minus, so minus has been taken common. So 1 by C. Cross multiply. This will be omega 2 plus omega 1 divided by omega 1 into omega 2 equal to 0. So if this is equal to 0, I can bring this entire term on the right hand side. Right, class? This can be brought on the other side, so as to make it positive. So omega 1 into omega 2 L is equal to 1 by C omega 2 plus omega 1 divided by omega 1 into omega 2. Omega 1 plus omega 2 will be cancelled from both the sides. So omega 1 into omega 2 is equal to 1 by L C. Okay, this is still about omega 1 and omega 2. We haven't obtained anything right now. Clear? This was when we had added. So we could only stop at this point. So second part is also over. We have obtained the equations. We have added them. Last part is subtract. Subtract those two equations which you have obtained initially, which you added. So this time it will be C. Same thing with the negative sign. This time it will be omega 2 minus omega 1 with L common. Here minus 1 by C was there, so this will be 1 by C. Here omega 2 plus omega 2, omega 1 was there, so this will be omega 2 minus omega 1 divided by omega 1 into omega 2. And C class, plus R minus R this time, correct? That becomes 2R. So here we'll have 2R. Earlier it was plus R plus minus R. That was 0. In addition, in subtraction, this will be added, right? Because minus will become plus. I hope this is clear to you why it's 2R. Now look, what we can do in this can be taken common. Omega 2 minus omega 1 can be taken common. So we'll be left with L plus 1 by C omega 1 into omega 2 is equal to 2R. Can you see, class, we are stuck here. We'll not be able to simplify this further. Nothing is being cancelled. But omega 1 into omega 2, we have already obtained it from here. That is 1 by LC. That's why we had added these equations. This was the significance. So omega 2 minus omega 1, L plus 1 by C. Now, omega 1 into omega 2 is 1 by LC is equal to 2R. Now, this can be simplified further. CC will be cancelled. Omega 2 minus omega 1 into 2L is equal to 2R. 2 will also be cancelled. What is omega 2 minus omega 1? Omega 2 minus omega 1 is equal to R by L. And what is now quality factor? Quality factor is resonant frequency by omega 2 minus omega 1. So final formula of Q factor is resonant frequency is there. What is omega 2 minus omega 1? R divided by L. This is the formula. For this simple formula, we had to do lot of calculations. It's a lengthy derivation. I agree. Okay, one more thing, class. You can put the value of, if you put the value of omega from your resonant frequency, that is omega is equal to 1 by 2 pi under root LC. When you'll solve all of this, you will get the formula 1 by R as under root L by C also. So this is a very helpful formula for numericals because resonant frequency is not mentioned everywhere. You will have to then use again the entire formula omega R. This is done by substituting. This is done by substituting omega R as 1 by under root LC. So if you have to put this directly, use this formula, right? Write the entire derivation first, step by step. Then at whichever step you get stuck, class, please let me know. Okay, now class, regarding your syllabus also of this batch particularly, not the other batch, this batch. See, this one more, next weekend we'll complete AC. I'm not rushing up with AC because your syllabus is stable, right? Your syllabus, because now ray optics is not left, right? That's why I am not rushing up with the syllabus. Next weekend we'll complete AC. We'll start with EM waves. And the next weekend, that is 9th and 10th, not 9th. I have already informed, I think Aliza wasn't there in the earlier class. Aliza is present right now, no? Aliza, next Saturday's class will be on Friday. I'm not available on Saturday. So instead of canceling the class, I'll prepone it on Friday. So please be free on Friday, Aliza, same timings.
Okay, ma'am.
Okay. Saturday will be off for you from my side. No class will be there, not the other batch. Everything will be as it is on Friday. You're talking about just Friday, Deborah, or both the classes?
Only first class, ma'am.
First class, only the first class on Friday, 8th.
Yes, ma'am.
Okay, then that ray optics class means.
Yes, ma'am.
Okay, okay. Then.